This is Professor Ming Ji for the Statistics in Nursing Research 3, and this talk is about a review of introductory statistics. The outline: I will discuss basic concepts of probability and statistics, and estimation, and statistical inference, and statistical modeling. Basic concepts of probability. So probability is about the study of random events. Random events are events whose outcomes are impossible to predict. So as you can see in this picture, this is an example of a random event. You roll 2 dice, and it's impossible for you to predict, how many dots you will see when you roll 2 dice here. Okay, no one can predict the number of dots when rolling dice with 100% certainty. So that's what we call random events. So we have random events, then other concepts of probability are sample space, relative frequency, probability, random variables, probability distributions. So here, a random event is a process which generates unpredictable outcomes. Then you may ask, so how do we study a random event since its outcomes are not predictable? Well, an idea is we can define a sample space. A sample space is the collection of all possible outcomes of a random event. So the idea of a sample space is, even though we cannot predict the outcome for each individual trial and each roll of dice, we can gather together all the possible outcomes of a random event. And then we call that as a sample space. So you can see in this diagram, you have the universal set, and then you have the sample space, and then you have event A and event B. So the sample space S is the collection of all possible outcomes, and event A and event B are subsets of the sample space. So after we have the sample space, and then we can run the random events process independently and repeatedly, such as rolling a die, again, and again. Then we observe the event of interest, such as if you flip a coin, you want to see whether you get a head. That's an event of interest. So we can define relative frequency. The relative frequency of an event of interest is the number of occurrence of an event of interest divided by the number of total simple repeated trials. For example, if you flip a coin 100 times and you see 49 heads, the relative frequency is 49 divided by 100. And why we need relative frequency is we use relative frequency to define the probability of a random event. Okay, so the probability of a random event is the limit of the relative frequency when the number of trials goes to infinity. So as you can see here, this graph, the x-axis is the number of trials, and the y-axis are the relative frequencies. So with the increase of the number of trials, the relative frequency eventually converge to a true value, 0.3, which we consider as the true probability of that random event. So after we have defined a random event, then we want to quantify random event. So we define random variables. So a random variable is a variable which takes values based on the outcomes of a random event. For example, we can flip a coin, and if we get a head, we can define x as a random variable, and it's associated with flipping a coin. If we get a head, x equal to 1, and if we get a tail, x equal to 0. Now this variable x takes values 0 and 1 randomly depending on the outcomes of a random event. So random variable is the quantification of random events. We assign numbers to the occurrence of random events. And in the introductory statistics course, you have studied many probability distribution. So how do we study the behavior of a random event? We study its probability distribution. The probability distribution of a random variable is a table or a function that completely describes the probabilities for the random variable to take certain range of its values. Okay, so the probability distribution is a complete categorization or description of the behavior of the random variable. So if we want to study the behavior of a random event, we study the random variable associated with the random event, then we want to really estimate the probability distribution of that random variable. And on this slide, you can see the graph of different types of commonly used probability distributions, such as the normal, the binomial, the Poisson, the uniform, and some other types of probability distributions.